So I want to determine whether this equation is exact and if it is, to solve it. So since it's in this form, we have m of x and y and also n of x and y as given here. In order to see if it's exact, we need to find partial m partial y and also partial n partial x. So this is only a function of x, so its derivative with respect to y is equal to 0. And n is only a function of y, so its derivative with respect to x is equal to 0. Then this equation is valid. And based on the definition of exact differential on the website, this differential equation will be an exact differential. Now we need to solve this problem. The steps are explained on my website, and the first step is to assume a function f, which is a function of both x and y, where its partial derivative with respect to x is equal to m and its partial derivative with respect to y is equal to n. So now we need to find partial f partial x, which is m. So then f, the arbitrary function, will be equal to the integration of m dx. And here, since f is both function of x and y, and the partial derivative of f with respect to x is m, then when we integrate m, we will have a constant which is a function of y. Then partial f partial x will be equal to partial g partial x, which here this will be equal to 0. So as you can see, partial f partial x will be equal to m of x and y. So since we have m, we can find f of x and y based on these constants. So f of x and y is partial m dx plus g, where m of x and y is given here. It's in the problem. It's 2x minus 1. This integration is trivial to obtain. And also we have gy as the constant of integration. Now that we have f of x and y, we can find its derivative with respect to y, which will be equal to n. So partial f partial y is equal to n of x and y. For the left-hand side, we can easily find the derivative of this function with respect to y, which is here. So since these two terms are only x, they don't have any y in them. So these two, the derivatives will be 0, and we will have only the derivative of g with respect to y. And since g is only a function of y, then we won't have the partial derivative. The partial derivatives will convert to the total derivative. So partial f partial y is equal to dg dy. And on the other hand, partial f partial y is equal to n of x and y. So then dg dy is equal to n of x and y. And n of x and y, as given in the problem, is 3y plus 7. So dg dy will be 3y plus 7. And if we do the integration, as you can see, dgy will be equal to 3y plus 7 dy. And if we do the integration here, we will find that gy is equal to the integration of this term plus the constant of integration. So now that we found the function of g, we can put it here and find f of x and y. So f of x and y is x2 minus x plus g. So we can say that x2 minus x plus 3 over 2y squared plus 7y is equal to c. And this will be the answer or the solution to the given differential equation.